Using these PMMA pipes for marble transportations everywhere in the machine was a stroke of genius. It works so well and it looks great. But these pipes are 22 millimeter wide in diameter and the whole machine is built on a pattern on 21 millimeter. Up here in the machine we have only 21 millimeter room for each pipe. So today I'm going to create a cool transition from the 21 millimeter center to a wider pattern that will fit the 22 millimeter pipes. So here's the marble divider. You can see the PMMA routing that we were going for, and we can see that this is the part that is now holding the PMMA pipe. I want paths that going from the 21 millimeter down here where we have a distance of 22.1 millimeter. These splines, these curves here are 3D splines. Normally you sketch in 2D, and I just developed a great method of doing that. So I go into the spline sketch, and I take it from this point and I try to choose this point. The second point I'm choosing here is located on another plane, and that's how you create a 3D spline. But as you can see, the spline is still straight, so then we need to constrain these green lines that are controlling the curve of the spline. So I'm gonna hit coincident and I'm gonna swerve around and I'm gonna choose this point and I want to constrain it to our perpendicular line like that. And now look what a nice curve we got. And then we just have to do the same up here. Bam! Perfect. Here comes the best part of all. All these lines are individual. You can see the leftmost line has much more curve than these lines because of course the distance is growing the further out we come. So I can take this line, copy it, paste it, move it over 21 millimeter, hit enter, right click this point, choose move, point to point move, select this point and move over to that point. Hit enter and I have a unique spline. This is different than that one, but it's a very automated workflow. I'm now working on the plywood pieces that I will use to build this up. I want this line to meet this line, and I don't want to use more plywood to reach there, so I'm thinking I can change the angle of this line. And this is where parametric design is so wonderful, because this angle, these sketches are made on a plane. I edit that plane and I can just change the angle. So if I put that maybe 20 degrees. Since I sketched everything constrained, now we have 20-degree angles and all my splines are now following. And as you can see now, the 24 millimeter plywood is more than enough. We can even do a less angle, 27 degrees. That looks good. So I'm using these splines to create a pipe. And I'm creating a pipe, but I'm not doing it to make a pipe. I'm doing it to make a cut. So I'm gonna hide this front plywood block. You now see that it's a cutaway. We can mirror all these holes over this mid-plane. Anytime you have something symmetrical to design, think mirror. So let's fast forward through the whole cam work where I made all the tool paths and we ended up with something that looked like a C. I can post-process this G-code and go down to the CNC machine. So this angle here is impossible to cut from above. That's why I'm machining this from two sides. All these positioning holes are symmetrical from the midpoint, so I can turn it this way and everything lines up. order to access the area where I want to mount this new spreader, I needed to remove the programming plates. Now I'm gonna show you the start and stop. Connecting the flywheel. Stop the machine, flywheel is still going. So I want to start again. What about that? It's held in place by a perfect press fit. Perfect. Perfect. Try channel 2. There we go. So when I'm working with the tubes, I can just push this up and away. Then when all the pipes are in, I can just wiggle this into place. So pretty soon, I'm about to sound check the kick drum. So I'm thinking we should bend the kick drum PMMA tubes. So I'm using TIG filler rod to create a template. Now I'm gonna cut it off. So this is an idea I wanted to try for a long time. I just mocked up a little heat shield here. So when bending these and heating them up with a heat gun, the heat is not really so even, but the heat shield will create a little bit of a heat bubble here that will heat up the PMMA more evenly. That looks pretty nice. So now I'm gonna make a little mark. Seems to fit great. Pushing that temporary in place. If I press here, will I get a marble here? One done, 37 to go, but this fits so easy up there. The whole purpose with this spreader is to make it easier to put the pipes next to each other. So I'm gonna make a second pipe to try that out. So I bent the second pipe. Awesome. Awesome. So me and Wilson's best friend are super happy with this new part. Look how happy we are. I think it's fun to show you these complex 3D shapes that you can make on a 3-axis CNC by splitting the design in the middle. It's a good trick. It can be very useful. It's 2 steps forward, 1 step back, but this was a step forward. Thank you so much for watching and good luck with everything you are doing.